This is the final work that we're doing on the roof of ASL-100. This is the US 10 trolley base, which exerts the upward tension on the trolley pole, which we measured a while ago at 25 pounds when it's up against the wire. We got this locomotive. It had two trolley bases, one here and one there, because apparently they had problem with what you're doing. It has one base where you have to swing a pole all the way around, and they must have had a place between buildings or something where they couldn't turn it around. We went back to the way it spent all but 1 year of its life when it had two trolley bases. When it ran with the one trolley base, they didn't have hooks, but where we leave our cars stored away without any connection to the overhead wire, we decided it would be the best practice to have hooks on here. The pole is hooked down. Now the main power for the trolley comes from overhead wire down through the trolley base. Notice this is aluminum, and the reason we do that is to make good conductivity between this pole, which is what carries the power, and this whole base, which conducts the power down to two wires, one on this end, one on this other side. And then this goes down to the circuit breaker, which is up high over the motorman's head, separate. So each one controls the motor on that side. The other thing that we have on the roof that is its finishing touch is this roof mat, which is where, if you had to climb up here to do any repairs, where you would go. And that's the original one, which had layer after layer after layer of paint. So we burned it all off and actually just burned it and scraped it off, and now it's back to its original shape. And as far as I know, that's all original pieces. The word trolley comes from the fishing term troller, and originally the very first trolleys, or cars, electric cars as they call them, had a little carriage that rolled along the wire overhead, and it wasn't a direct connection like a trolley pole, a rigid connection. It was just pulled by a cable, which must have been kind of interesting, because when the trolley stopped, this little cart ran ahead overhead. But anyway, they were gone long ago, but the word trolley, which is sort of a slang for troller, did stick. And the first type of trolley device that they had was a wheel at the end to conduct the power. And you can see it over in the car next to us. And when we got 100, it had a wheel on the end of its trolley pole. But we know that a trolley wheel, when it rolls along the wire, sparks a little bit and leaves roughens up the trolley wire to the point that a carbon shoe, which is softer, would be torn apart. So for our operating fleet, all our cars have carbon shoes on them, including this. It's not that they ever had any such thing as that in this locomotive in real life, but it's an operating practice that we feel, as long as we acknowledge it, we have to do. The car next to us will be taking that wheel off and putting carbon shoes when we finally use it, but for now, we'll just leave it the way it is. This is just a lantern battery and an ordinary doorbell on it. 6-volt doorbell. 2 wires going on either side, and we use this for detecting continuity. That is the electricity getting through something? So looking at this diagram, we could see where the electricity is supposed to go. And for instance, we were looking to make sure, let's say that we want to know if this resistor is good. We'll connect to R2 and R4, and we should be able to hear the bell ring. So down inside of here, we happen to have these labeled so we can tell what they are. I can get around it anyway. These wires go back up into the controller of the car. This is okay, where did we say R4 was? It's right here. Yeah. It's going to be the more exciting episode of this. So we know we have continuity through from here to here. There are taps down on the bottom of these resistors which correspond to these little wires, little dots right on here. What we were concerned about, if you just looked at this, you'd think that all of this was connected as one unit, but there's not supposed to be any power between here and here, and we just determined that there was not, because on one other car we did, there was, and there were spectacular sparks when we started the car the first time. So we wish to avoid that, and we have done so.
Now we also have checked the controller. We just finished.
Yes, we just, what we did on the controller, this is the drum that turns around. These represent the fingers that make contact, that slide over as the drum turns toward it. And what we were doing, we rang out each one of these, first of all from one controller to the other. This is the number 2 end, the number 1 end. So that you made sure we had the same connection made in both of them. And then we did the same thing on the reverser. FAA, this is motor number 1. F1, AA1, and FF1. Field, armature. There's also the other end of the armature is right here for A1 and for the armatures for 1 and 3, and this is for motors number 2. This is what they call a cutout switch, but we weren't concerned with that at this point. So we wanted to make sure that every motor was wired. Now what we're going to do is we're going to check from here to the motors which are under the car to make sure that the motor, that the wire that hangs down is by motor number 1 is really that wire. So I guess we can do that. The motors in ASL-100 and its controllers and the resistors is all in this schematic drawing, which is was drawn by the General Electric Company the 23rd, actually interestingly enough, 23rd of August, which was yesterday, 1913. We didn't, when I was first volunteering here, we didn't have ways of copying things, and I seem to have a lot of time on my hands, so what I did back in 1965, the 23rd of December, is I copied this, and since then we've used many of these. And this is what we're doing today, is just making sure that the wiring, which all of which was replaced in the car, is correct.
Okay.
What we're doing is connecting, assuring there's continuity between the wires that actually go to the motor and the control upstairs. And what I've done, there's a connector right there with set screws holding it in, and I've taken this little bit of insulation off of it so we can get the bare connector, and then when we're through we'll put it back. So upstairs, this connector is supposed to be FF2, that is the field lead for a second motor, for motor number 2, and we should be getting the same contact down below. And I'm checking the tags that are on these wires, but I can't see this close up with my bifocals and having trouble doing this. But this is very important because we want to make sure the motor goes the right direction. All right, you want to see if that's FF2?
Okay.
On every motor, there are 4 leads. 2 for the fields, 2 for the armatures. F and FF refer to the fields. When we connect to one wire, we're going directly to the motor. When we connect to the other wire, we're going to the motor through the field from the other end. So in order to tell which is which, the strong, when it rings strongly, we'll know that we're going directly to it. If he's upstairs connected to the F wire, F2 wire, because this is the number, this is the second motor, number 2. If you're connected to the F2 wire, upstairs and downstairs, it will ring strongly. If he moves his contact over to the FF2, the other end of the field, he'll get a weaker ring. And that's sort of a rough test that you make sure you're on the proper end of things. This is the FF2, and I believe you determined that, so
Yes.
we can...
Yeah. And let's see where F2 is. So here's F2, and here's F2. So F2 in this case is weaker than FF2.
We're working on the number 2 controller of ASL-100, and we're placing all the segments. These are the things that make contact when a finger presses against it. We're using some new, and we're using some original, and we're using some that are have been overhauled. This is what they call the lock type. We've been over this before, and you see how that locks right in there like that. And the segment screw goes down through here. Now I'm looking at a little chart next to me, and I recorded everything we took out of here. This is the controller that was in 100, and we salvaged, or we indicated everything as it was when we took it out. So I'm using, these are little segment screws, special made, 40 cents a piece, GE part number 40037 with a special 1424 thread on. There's nothing you're going to find in a hardware store. And notice the countersink, how shallow that is. It's a rather sharp one, rather than like the 82-degree ones that you get in ordinary screws. Those are new screws we're using because the old ones get burned up. So now let's put this original number 6 segment in place here. Screw that in lightly. And by the way, I've stamped on the drum also number 6, so we know they go in that spot. That way there's no confusion whatsoever. And then we put the little lock type one on here. If I can get it to line up, it all should go back together just like it came apart. These new lock type tips were $17.50 a piece because apparently there's a lot of machining in them, and nobody except myself and Dave Johnston of the Bay Area Museum buys them because they're an obsolete type, and unless they're kept tight and put in there exactly right, they tend to fall out and gum up the works. So I'll give this an extra twist to the screwdriver just to make sure it's tight when we get around to that point. They were replaced by the lap type, which is right here, which has a little bit different end on it. I hope we'll run into one soon. Okay. Oh, I think that's probably all.
Okay.
This is controller number 1, and it's all the parts are in it. Now we're doing various adjustments to make sure that it operates correctly. It'll be a semi-final tuning. What I'm doing is moving it around and checking. It's quite a jump right there. Something is very stiff. So you can adjust. Let's look right here. Watch that fingertip. See how that lifts up? Well, we have to have all of these lift about the same amount, and if some of them go too far, they get harder to lift. So what I have to do is, and there's different types of fingers here. This is sort of as it was when we found it, a mixture of all kinds of different fingers. We'll talk about that in a minute. But see, what I'm doing right now is that's supposed to raise an eighth of an inch. Now this is a 1/4 inch thick. So when this finger is at the bottom, it shouldn't be all the way down like that. It's lifting well over a 1/4 of an inch, which is much too much. So I tighten that. You can see it gradually moving up. So that lifts an eighth of an inch. And I think things are going to get easier as I go. Push that in the other direction. Alright, it's still lifting more than it should. I haven't put any lubricant on this either because I didn't want to until I was through. Alright, I'm working my way up. Let's look at these two here. I also need that light. Alright, there's something that's making that work very hard right in there, and I don't know what it is. Let's see what this one is here. See if I can go up a little bit with that one. not doing anything, so we got to drop that one down. And it doesn't do anything yet, so we have to do something else. Keep going back and forth here till we get it about right. Ed Dukes, who's one of our volunteers, loves to adjust these things, and he will come back through and make perfection of my rough first guess. I just want to get it so it will make contact when we try to run the car on 600 volts, maybe as early as tomorrow. When this controller goes around, the segments are these. They're called segments because they're portions of an arc. There's a circle 5 1/4 inches in diameter, and these segments bend around that. They make the contact between the wire, the finger, and the segment. Everything's copper here, and this is all one connection together. So when you do this, the electricity is going from here to here. When you go further along, it's going from here to here, and finally from here to here. These fingers have been developed over the years. The most primitive ones are these right here, and the ends of these fingertips are, instead of being bolted on as the more modern kind, this finger has a piece of copper molded right into the finger, sticking out. And then we did what was called peening, which I think we showed.
We did. Yeah, we did a segment.
We peened that down, and it's a very solid hold. In fact, when we took the old ones apart, it was all we could do to get them off. So we use this type of finger because that's what the controllers had, not because it's any better. And fortunately, we were still able to get them. I guess nobody's buying them, so they're sitting in the factory. So that's the most primitive type. Then this type right here is called a Russell reversible fingertip. This finger you can turn right over. If it's burned out on one side, you flip it over, and you get a new surface right there. And you can see just a little bit of wear on this. It probably would have been fine the way it was, but I wanted to turn it over. Patented December 6, 1910. They were made actually in Niagara Falls, Ontario, but they had an office in Niagara Falls, New York, and I did buy some years ago, and then the company went out of business and there's no way to get any more. Then the most modern type is this right here, and this is called the compensating type, and it's a little bit more flexible. See, this one doesn't bend much, and if there's a slight misalignment, you don't get a good contact here, whereas this one, you get quite a good alignment. And then you have the adjusting screws on all of them in different places. So this has a kind of a mixture of all the different types here. As basically what happened is I ran out of these original ones, as they had when the car was running. It came to us with a mixture. They must have just gone through their stock room until there was nothing left, which is just what we had to do. Now I've also talked about, but you can actually see them now in place, of the two different tips on these. This is just a solid piece of copper, and when you shut off the current, if you don't do it properly, you'll get an arc between here and here, and it will melt that away. Both of these will tend to burn away, and you'll have to end up replacing the whole thing. This says new on here because it was new to the job. Some of them we reused again and cleaned them up. This one has a burning tip because, watch this as it goes around. You see how far that would be, and you'd hate to have to replace that whole piece of copper. So this one has a burning tip which is removable. Now that's what they call a Loctite burning tip. Which I know we've done this before, but we'll do it again. It has this is an old one that I replaced, and there's a similar edge that goes underneath that is matches that, And supposedly that's going to lock and hold in position. In theory, that's right, but it turns out that these screws, now I tightened this in, well, okay, I tightened these several times. You'd come back and find that the metal had stretched a little bit. So as this gets hot, the screw is stretches, and it will allow this to loosen up. You should go back and tighten them every week or so. We don't, or we haven't anyway, because we haven't got many of these in service. So we have those two different types of tips. I'm going to show you in the other controller, we've got a more modern, what they call a lap type. They have them on both ends of the segments, both for coming on and coming off. So that controller is much better than it was before we started what we were doing here. So let's take a look at the number 2 controller. Which one is which with the light? Yeah, there's a light. It may show better actually.
So this is the number 2?
Number 2 controller, yeah. I was looking to see if we had one that you could show better. These are all lock type. Well, maybe you can get the light in on top of that. Yeah, there.
Yeah.
All right, see how that overlaps with the step? This gives a much better contact inside, and it's called a lap type because it laps over one to the other. And this replaced exactly what was in here before. The company, this is the original one in the Locomotive. The other one was the one that we had to replace because the first one had been stolen. So we use that type of controller. Now we had more of the old style of fingers here, so there's only 2 of them I think that are of a different style. And the Atlantic Shore would have done the same thing. They would have gone through whatever they had left over from whatever car that they scrapped and had taken all the parts out of and used them to make it go. Now the other thing that I was doing when Phil came in here was, if you look inside of there, you can see the segment turning around, and here it is matching the finger, and that moves. Now what had happened was somewhere down in here, not important which one it was, but the tip had slipped just a little bit and it was scraping on here, so I could only go this far and then I couldn't go around the rest of the way, and I need to do that with the other control. But now it works fairly evenly. If you have this too loose, what happens is you'll slip by a point. If you have it too tight, it takes 2 hands to operate the controller, which means you've got nothing left for the brake, and you can't get good control with it. But even without lubrication, this I think is pretty good. Now, just a reminder, we had this controller apart almost to the last screw, every last little part, patched up. This white is a Sauerreisen, which is a calcium silicate, which hardens up and fills in all the holes, and then we sand it down smoothly, and it works quite well. This is the second or third trial. We have reversed the field connections on motors number 2 and 4. Those motors are cut in, that is, that they are actually working. Motors 1 and 3 are not working. That way we narrow down the amount of possibilities of the motors trying to go in opposite directions. We just tried the number 2 end, and the car ran properly. That is, it ran forward when I pushed the handle forward and went backward when I pushed the handle back. There was a little problem with some bumps in the controller, but that's a separate issue. So here we go. We're going to try to go forward. Amazing. Down. All right, next step will be to pull the pole and try the other 2 forward, this direction, and now we'll go backward.
So what motors are these?
This is motors number 1 and 3. So from this end anyway, 1, 2, 3, and 4 all go the same way. But we've got one more test here, and then we're going to try them all. same idea. Okay. Now, one more thing to do.
What's that?
The moment. We finally cut in all 4 motors, and hopefully they'll all go in the same direction. Wow. There's our break.
So this is where you get a high five.
All right, one more, and then that's it. We're done.
We're done. She got some giddy up.
Yeah, she is. Yeah, I don't dare go any more than that.
Oh,
Just want to. He's going up, up. Okay. Okay, put it up and leave it up.
put it up and leave it up. I hear a leak.
We may be open downstairs. Dick, we opened up downstairs.
Working on this side and the black one on the
Because
other.
it's shut. This is fed from downstairs here. Did that? Aha, 95.
All right. We got the ground set up so the lights work inside now.
This is the light switch for the cab lights. It contains a small fuse, small cartridge fuse, very difficult to get. It's called a enclosed fuse switch combination. The lights are 5 in series, so we just went through and checked the continuity for every light to light to light and wondered why it didn't work.
Well, we changed the fuse first. Check
Changed it. All right, there was a bad fuse,
Yeah.
which didn't help anything. And then after that was corrected, then we went along and rang with our buzzer. Actually, it isn't a buzzer, is it? To here, and then we tried to get to ground, which is the end of the circuit. There's this wire that goes here and it disappears down here. It turned out it had never been connected, and so we had enough length so we were able to find a ground connection in the controller, and it's now functioning.